Hello and welcome everyone back to my another tutorial related to transformers. And in the previous tutorial I show you how to write a full pipeline, how to train your custom transformer in TensorFlow to make a translation from one language to another. And I made a tutorial specific for Spanish to English translation task. And I should agree that I don't understand Spanish at all, and I simply made this tutorial for you to make an example how you can train this kind of transformer from scratch, how you need to save the model, how to convert this model into ONNX so you could port it somewhere else and use it for inference. So right now I will cover how long it took me to train the model, what accuracy I achieved, and I'll show you what exactly I achieved and how to run the inference of translation and so on. So beginning from this, I should mention that this training took me a lot of time, way more than I expected, because the dataset is pretty huge. There's 1 million different sentences in this dataset. I specifically used the Corpus Opus dataset, and this has, as you can see, huge files. And I don't want to open these, but basically there's 1 million sentences in English and Spanish languages. So yeah, I completely trained it, and I'll publish my model so you could download it and try it by yourself if you're interested. So let's jump straight to the tensor board, because I believe you're mostly interested what I achieved. So let's go. And this training took way more than I expected. As you might see, it took me 6 days to train this transformer. That's a lot compared that this is for fun. And yeah, I was able to run this for all this time. And why not? I thought I was able to hold the training. Right now I don't know if I would like to, because I didn't need to use that computer on which I trained it, and the GPU was free to use. So yeah, simply I trained it. And you might see that yeah, we can look at the loss. And basically there was a masked loss, but it's simply called loss. And you might see that it was decreasing step by step in each steps. And here is a training in orange and in blue validation. And yeah, it was totally nice to train this. And yeah, we don't need to care about the training. We basically care about validation loss. And we can see that it was constantly decreasing. And I believe somewhere here it achieved its best. But still there's an early stopping for several epochs, and I continued to train with that. So great. And you may remember I used some special callback for learning rate, and you might see how it looks like. The training started at this learning rate, and in one epoch it increased to this, and it held basically the same learning rate for one epoch, and then gradually started to decrease following the cosine curve. It was following here, and here started my another callback where it was detecting that model is not improving, and it slightly was decreasing the learning rate by 0.8 ratio, I believe. And it continued training, and so on. So basically we can see that if it was not decreasing here, this means that my model was improving and it was saved somewhere on disk. And yeah, I believe it stopped somewhere here, as we can see from the loss curve. But basically we were tracking the masked accuracy, and we were using it to track our best model, and we were saving on this masked accuracy. And basically I believe this one was the best. So it's simply trained for maximum epochs. I was set there. I set the 50 epochs to train, and basically it achieved it here. Yeah, that's cool. And it trained, but it achieved only 0.86. This is 86% accuracy. And we know that in machine learning, that's not the best accuracy we would expect, especially from such a large data set. But we know that our model wasn't very large. It had only 7 million trainable parameters together, encoder and decoder. And we might see that, well, at least we know that it trains. And of course, I do not recommend training for you from scratch because you need some large, like a GPU, and there is no use at all with this kind of Spanish language. I believe you could find a better solutions with this, or use open source already pre-trained models to achieve this translation. And yeah, we are not interested at all about this. The purpose was to show you that it works, it trains, and etc. And we can go to the code to see basically how to run this model. Let's go here. I already wrote a test script in my transformers tutorial. This one used to train, and I created this test. And here is my models. Of course, there's many files, but I'll give you explanation what they are and where they should be used. And yeah, and so I created this model to run on ONNX. So this means I'll use this model ONNX for my translation. And let's go to my files. As you can see, these are the models, and this one is the trainable Keras model, 91 megabyte, and I converted this to ONNX. It's not 49 megabytes, and yeah, we'll use this for inference. And you might ask why I convert this to ONNX. Basically, there is a huge reason. The transformer is a custom model and etc. This means that I trained this, but if you would like to load this model and load the weights, you might face some difficulties, the layers mismatch and etc. And if you want to deploy it somewhere, it's really hard to load this model because you'll need to install the TensorFlow, you'll need to define all the layers and etc. But when I deploy this into ONNX, I don't need all of this. I need to install ONNX runtime, and I can load the model, and I will be able to run the inference. So basically, I'll show you example. What does it mean? So from the beginning, this is an object, but we'll come here in a moment. Basically, I copied the read files function from the training code. Then I defined the paths to my development test data. Here, a few functions that I use to read this kind of data set. I limit the length, of course, the same as I did in the training, and then I simply create this translator object that I define above. And right now I'll run this simple code to show you how I do this translation. As you might see here, there is my Spanish sentence and English sentence, the true English sentence. I'll give you a comparison between these when we run the inference. So I add here a breakpoints, and basically we'll come at first here to see what does it mean, all the stuff. And you might see that I'm using the custom tokenizer, and my tokenizers are saved as dictionaries here, but I will load these not from here, but I will load this from my ONNX model. That's another advantage that I can use. So let's run this in a debug mode. Give it a minute. And it stopped here, so let's go inside, let's create this model, and you will see that it already it's loaded. Okay, it stopped there for some reason, breakpoint and etc. So if I open the self, there will be already my model defined here. So this is my ONNX model, and Nothing special about that. It has some input shape that it has the path, the file model name, and here is the metadata. That's the tokenizer from this model that I saved this inside the model. So we'll use this tokenizer to do the project. And of course, we have the tokenizer. So tokenizer we use for Spanish, and the tokenizer we use from tokens convert to English. So simply let's load this. And this is as dictionary, as you can see, my metadata. And I load this into my object of tokenizer, the tokenizer. And right now they will be here ready to go. Okay. So this object was initialized, and let's go step by step right now here, and let's see what I have when I do the iterations here. So here I have my Spanish sentence. I don't know what it means. And here's my English. I don't even remember what the fight was about. So this means that we should get the same translation from the Spanish sentence. So let's go deeper inside step by step, and let's look how it works. So that's for interest. We record the start time, and here is my sentence, the Spanish sentence, and I would like to tokenize it. So I use the self tokenizer text to sequence. Okay, tokenize sentence. Right now this should be on some integers that I will use. So that's my tokens of this sentence. And next, I need to pad this to match the length of the input to my model. So my input is the maximum length, so I need to pad this. Okay, let's go. And right now it is padded to one sentence, and this is my padding tokens and padded with zeros. That's great. Now I need to create a detokenizer padding token. So in transformers, we need to input output of decoder back into the decoder layer. So but what we do if we don't have anything what to input? So we create a simple list with a start token. So that's why I use this start token. And what does it mean? If I look at it, start token is simply a start. So great, let's move on, and we'll see that it's a list of 33 one start token, and we iterate the maximum length of it, and we'll record the index. So great, and we pad this decoder stuff, tokenize the results, and we already have the decoder input. So it's 33 and padded with zeros. So this means we don't have any sentence. And next, we need to construct a dictionary that we feed into ONNX, and it requires a specific shape. And if you are implementing this as custom stuff, take attention to these kind of names and shapes, what the input is required to be. Right now, both inputs are integers, integer 64. So we simply create this input dictionary. And if I look at this input dictionary, you'll see that there is my Spanish sentence tokens and my output tokens. And because there is nothing there at the end, only start token, this is only 33. That's great. And now we can input this into the model, and we'll receive some predictions. What do we receive? So we receive an output from the model where there is my whole dictionary. It's 1055 different output tokens, and there is 502. So this is the maximum length of my decoder output. And what we need to do, we need to find the argmax of these. So we simply run this, and we receive the prediction results. And the prediction results are 52, followed by some unknown number. It can be anything here, but we are mostly interested in the first token. It's 52. Okay, so we take this first token as our index tells, and we append these results to our tokenized results. And we go on, and Right now we'll have 33 and 52, and we're not sure what it means yet, but as we achieve this n, we'll detokenize it back to the string. Okay, let's do this. So yeah, if I run this again, it will iterate here back. But when it achieves and it finds that token that is equal to 32, that is equal to token index, it will break this loop and will use the results, these results, to detokenize it. So great, let's run this, and after a while we receive these kind of results, and we are not sure what they mean, but what we do here, we simply run this again, we detokenize it, and we receive an answer. I don't remember why it was defined. Okay, so this is our Spanish translation. So I'll run this again, and I have the results. I have the duration, but it took a lot of time because, well, mainly I was explaining it for you step by step what's happening there. So I have breakpoint here. So let's go to it and let's log the results to our terminal. So actual translation, what there should have been, it was, I don't even remember what the fight was about, dot. And our translation is, I don't remember why it was the fight. So it doesn't actually represent the true translation, but it's something similar to this at least. Okay, let's remove these breakpoints and let's look again. What we have is another example. So here are the size of each of those that have taken place. They are the places in which each congress has taken, well, definitely the mean is different, but at least words are pretty similar to what we were expecting. Okay, let's run again. And right now, let's see, I'm the man who killed Blackbird. Okay, that's cool. And I'm the man who killed Barba Negra. That's not the same, but that's only one word that is wrong with it. So this means at least my translation with this transformer works. And if I move again to another example, I don't get smart. I don't make the smart one. Okay, it's a similar translation, but it's not accurate. Okay, this is different. Is there an example? Okay, the true answer should have been pretty long, and we received pretty short. So this is also gives me the wrong. This was simple, and it translated it 100% correctly. And yes, Joe, and yeah, Joe. Well, it's different, but it works. It works. So you might see that it works. Why 2 months? Why 2 months? That's 100% correct translation. And this means that my transformer actually works, and you might see that I'm not using any TensorFlow and Keras to run inference with my model. I use pure ONNX model that I show you there, what I saved and etc. So this means my transformer works. And one more, how I can improve this? Well, I could expand the depth and size of my transformer by increasing attention layers, number of heads, encoder decoder layers, and etc. But this wasn't my priority to do so. I simply wanted to test out how I can train the transformer from scratch. And it seems that everything works, and that's pretty nice. With a one negative side that it requires insane amount of power and GPU computation. So this means that it's really hard to train these transformers for such a task, but this is language translation that actually works, and what I was mostly interested in, to make working transformer as example. And we covered this from the beginning, from the theory to this step where we can use this kind of in a production. And I run this in GPU, so you might see that on CPU it would be pretty slow, but I believe there's a lot of ways how we can achieve better accuracy, better speed of this, and make it more efficient. But the goal is was at least to make it to the end, to achieve some good results, to make sure that it works, and etc. So that was all the goal of this tutorial. And of course, I will upload this model into my, I don't know, some drive, so you could download if you're interested. And you might see that here I show you there is way more files than modal and modal ONNX. Well, there is a theory that when we split decoder and encoder into different models, well, basically, we need to use encoder only once, and decoder we can use in a for loop. So simply, we could run encodings here, and these encoder results feed to decoder in the loop. But I was testing this out, it didn't work for me, and I didn't have time to debug this. So for now, I decided that I'm not investigating and spending time on this bug. And I believe there's somewhere bug in my code, but I removed all the code because it's not necessary, because it's not working. And it's enough for us to train the model, to have model H5 and ONNX to run this inference. And tokenizer, yeah, we would need to use this if we would run inference in Keras, but right now you can see that it's enough to have this one file, and it includes the tokenizer and the tokenizer. That's pretty amazing, and we don't need anything else. And it don't take a lot of space. It simply runs pretty slowly, but that we can solve. So that was the goal of my tutorial series, to show you how transformers work, how to train them, and etc. for different tasks. And I believe that's it about these tutorials. And right now we train this for language translation. Maybe in the next tutorial I'll try to use this for speech recognition, as I used in my previous tutorials. Yeah, this one, 5th tutorial, sound to text, where I used CTC laws, and I'm interested how this would work with transformers, but the same. I believe it would be better to use some kind of open source model and to add a head on it and fit on this model, not trained from scratch. It would give us way better results. But right now that I'm learning, it's not the purpose to make the best model there possible. And that's it about this tutorial. I think that's what I wanted to show you, that it works, it took me tremendous amount of time, but still I completely trained it, and I'm very satisfied and happy how it works. And I believe you might learn how to use this from transformers from my tutorial. And if you like this guide how to use these transformers, don't hesitate to smash the like button, share, ask any questions if you have in comments, and don't hesitate to like this video if you already watched to the end, and subscribe for more these like videos. And the link to the code of the model you can find also in description, and link to the text version tutorial with all the explanations also you can find in text version tutorial. So thank you again for watching, and we'll see you in our next time. Thank you, and have a nice day for you. Bye.